So in this case, we are going to consider our typical exam revision of our mathematics grade 9. This is another typical exam question that we are going to have just to cover up some of the topics that we did together and some of the topics that we did not manage to cover up as we had our year going. But with the information that we have, we can be able to revise. Just make sure you revise at least 3 question papers before your exam. You revise at least 3 question papers. You see that they do repeat like the way they ask these questions. All right, so not wasting much of your time, guys. Make sure you go through your instructions and information. All right, mostly important for your answers to be to 2 decimal places unless they state otherwise, unless otherwise stated. So we are not going to waste much of the time. On section A, which is question number 1, you were given, answer the following questions by circling the answer, the letter next to the correct answer. So 1.1, you're given how many terms are in the expression. This is the given expression. How many terms? How many terms do we have? We are given this is a term. Remember, if you're given a bracket, let's say, I want you to understand this, guys. X plus Y like this is referred to as an expression. But the moment we take this and raise to a certain exponent, maybe it's 4, it's 3, whatever that you're given, we are now considering this whole part as a term, as a single term. Take note about that. We are consider unless you have to expand this, but as it is, you have to consider it as a term. But the moment you expand, whatever that you expand, maybe you've got x squared plus whatever that you are going to expand later on are now terms. 1, 2, 3, these are now terms. But as it is in a bracket, you can consider it as a term. All right? You can consider, it's just like a product, A, B, to the exponent of 3. Consider this as a single term. So you have to be very careful in that part. So in this case, let's see. There's a division, but the division is on this term. This is where the division is. We are not given a bracket and the division later on. No, it is just divided, meaning to say these are the 2 terms that are going to divide each other. So we've got minus 3x minus 1 to the exponent of 3 plus x. These 2 terms are going to divide. So it's minus x4, which is same as 4x over what? Over x squared. So we can count to say this is a single term, this is a single term, and this is a single term. So it means we've got 1, 2, 3 terms. So the best answer there was going to be B, where we've got 3 terms. So like I said, you can consider that bracket as a single term when it is a bracket like that. 1.2, which of the following is not an example of a rational number? Is not. Which one is not? Remember that a rational number is the one that we can express in the form of A over B, where A and B are both these, A and B are both elements that we have for the what? For the integers. These are integers where B cannot be equal to 0. Remember your definition of a rational number. If it can be written as a fraction like this, where A and B are integers. So let's take 5. 5 can be written as 5 over 1. We can see that this is a whole number, this is an integer, this is an integer. So meaning to say this is what? A rational number. This is an example of a rational number. What about the square root of 5? The square root of 5, we do not even know it. There is a decimal that is an endless decimal that we are going to have. We can whole number over that on the square root of 5. It's impossible for us to have this. All right, let's take our calculators, guys, and see. Remember, you are allowed to use your calculators. So let us just take our calculator and see what I'm trying to say here. This is the square root of a 5. This is square root of 5, which is as a decimal. All right, it's because I fixed my calculator to 2 decimal places. Let me go back to the normal mode. Shift, then you're going to press 8. To the normal mode, you press a 2. So as a decimal, as you can see, 2,36067977. It's an endless decimal. We cannot rewrite this decimal. Remember, this is not a recurring decimal. It cannot be written in the form of A over B. It's not. So the best answer there was going to be B. All right, this part C, which is 2,5. You can even use a calculator there. If you're not good in these fractions, guys, the calculator is there as an assistant. So meaning to say we're going to have 2,5. All right, that's 2,5 like this is equal to, just use your calculator, straightforward on that part. So you can see that it's 5 over 2. 5 over 2. So 5 over 2 is a rational number. If we are to write this 5 over 2, that is a fraction that we are having there, where 5 is a whole number. Okay, we got 5 over 2. This is square root of what? So means of 1, A over B, where these are integers. It is also a rational number. Was question that we are given on 1.3. We are given to choose a statement that describes how to determine the next term in the pattern that you're given. So the term, the third term, and so on and so on. So they're simply asking you, what is happening here? Are we adding 2? Are we going to add a half? Are we going to multiply by 2? Are we going to multiply by a half? So if you check, we are given already. See what is happening. If we add a 2, what is going to happen? From the first term is 1. Okay, let's take our first term and see. This is, guys, this is multiple choice. Just take the number that you're given. The first term is 1. Okay, they're saying A, add 2. So let's add 2 and see. We add the second term, it's a half, not a 3. So this is totally wrong. Add 1 over first term is 1. We add, that is, we're going to take 1. Remember, we have our first term. Okay, let's just stop. This network is not going to affect us, guys. That's 1 plus, they say add a half. Add a half. 1 over 2, that is a half, like this. We're going to obtain 3 over 2, which is same as 1.5. But then we are given a half, not 1.5. So this is totally wrong because the next term is not 1.5. The next term is what? A half. So this is totally wrong. This is direct lines. 1 times 2 is what? 1 times 2 is 2, which is not what we have. Okay, let's just multiply 1 times 2. What we have? That's a 2. This is multiplied by 1 over 2. Okay, let's take 1. I'm going to take 1. We multiply it to 1 over 2 like this. So this was going to give us 1 over 2, which is exactly what we have on the side. The second term is 1 over 2. Remember, we are multiplying by what? By 1 over 2. So if we multiply by 1 over 2, are we obtaining the next term? All right, this is 1 over 2 here. 1 over 2. This is 1 over 4. So as you can see, 1 over 2, the next term is 1 over 4. Let's multiply it by 1 over 2 and see what you're going to have. By 1 over 2, this is going to give us 1 over 8. Exactly what we have, 1 over 8. So meaning to say this is exactly what is describing the sequence, the pattern that we are given, or the statement that we are given. We have one term going to be on D. All right, so D was going to be the best answer. 1.4 minus this. All right, let's just combine 13 squared. That is 13 times 13. Remember, that's 169, which is 25. Then we need the difference between these two. 169 minus 12 going to give a 12. Remember, the square root of 144 is 12. 12 times 12 is 144. So the best answer there was 12, which is on what? Which is on C. Given that substituted, guys, direct on your calculator. Not this is, you remember, you're already given the answers and it's 1 mark. So you can just even use your calculator straightforward. All right. So that one, you can also take advantage of the calculator. The square root of what? Minus 5 squared, as it, the way that you see it there, minus 5 squared. All right. So this was going to give us a 12. As you can see, we are having the same answer. So you can even use a calculator when it is like that. All right, given by the formula in the table given above, the relationship is the one that maintains this rule that we are like the input giving us. So without wasting your time finding the equation, finding the gradient, this and that, you can simply substitute, just like what we did on this, on the previous question that we had to test the answers that we are given. It's already the rules are given. This is section A, guys. We are given the answers already. So test your answers. A, we are given plus 6. So let's test. If x is minus 12, are we going to obtain this? If not, then it means it's wrong. You move on to another one. All right. So let's substitute. In place of x, we're saying x is what? Minus 2. All right. So this one, there's no need for bracket, just minus 2, 4, which is not minus 9. So this is totally wrong. You can test another one. Test, you see that you're not going to get the output as it is given. So the first one is totally wrong. It is not giving us the corresponding value, but it is not. You move on to the second one. What is the value of x? If x is minus 2, we're going to substitute a minus 2 there. So that's minus 2 like this. A minus, that's a plus. So it's 2 minus 4. So y is equal to 2 minus 4, which is what? A minus 9, not a minus 2. So this is totally wrong. So meaning to say this rule or this formula is totally, if it is going to give us exactly the minus 9 that we have to minus 2x, so x is minus 2. So that's minus, minus, that's a product there, so it's going to give a positive. So that's a -5, which is wrong, meaning say this rule or this formula is wrong. Okay, what about the last one? Y is of x. What is our x? Our x, remember, is -2. So 5, what are we going to have? So that's y is equal plus a 1. So y is equal to what? -10 plus 1 gives us what? A minus here on the output. Y is what? Y is a -9. So you can see that if x is -2, y is -9. This is the formula which is exactly giving us that from the input to the output. It corresponds. So the answer there was going to be a D. Or you can use the exact way. Remember, working with your, when you're dealing with the relationship, the formula, it is the equation of a line that you're going to have. So you can use the gradient concept, where you have to find the gradient. You substitute any of the values that you are given. So we could have worked it that way. Remember, this is a linear function. You can see that there's a difference of 5 throughout here. There's a difference of 5. Take any points of you to find the gradient. Remember, m is the gradient from this. Remember that the equation of a straight line is given in the form of what? Y is equal to mx plus c, where m is the gradient or the difference that we have. If you subtract here the difference, -4 minus -9, that's a 5. -4 like this, it is going to give us a +5. That's a plus here. 6 minus 1, that's a 5. We can see that's a linear function. So a linear function, you write it in the form of Tn is equal to Bn plus C. This B, the difference, is the same as this M. So you can even use the gradient concept. So that's 5x plus C. Remember, C on a graph, it represents the y-intercept, where we understand that in the y-intercept, x is equal to what? X is equal to 0. So you can take advantage of this point. There is what? There is a 0 there. Where x is equal to 0, what is the equal to 1? On the y-intercept. When x is what? When x is a 0. So x plus c, the y-intercept is what? Is 1. So that's an equation. So we can see that we are still going to obtain the same answers there. There are so many ways, guys. You can use any way that you D. Okay, we indicated that's letter D. On section B, question number 2, we are given 2.1. Write 27 as to 35 in its simplest form. This is a ratio that we are given. Do we have any number? The highest common factor is 7. So you can simply divide by 7, divide by 7. 21 divided by 7, that is a 3. 35 divided by 7, that is a 5. So in simplest number that we can use to reduce these. Use the ladder method to determine the prime factors of 36. Using what? The ladder method. What are the prime factors of 36? Write your answer in exponential form. You are given what to do on the final condition in exponential form, just like this. So remember your prime numbers. The smallest prime number is 2. So we can actually start with a 2. We divide 36 divide by 2. That is going to give us 18. We try again by 2. 18 divided, because 9 divided by 2 is not going to give us a whole number. We need exact. Remember, these are factors. When you divide, you're not supposed to have any remainder. So you move on to the next prime number. Remember, prime numbers 2, and these are prime numbers. So when you see that 2 is no longer applicable, move on to 3. So we try 3. 9 divided by 3 is what? That's a 3. Okay, 3 can be divided by 3. So let's divide 3 divided by 3. That's what? That's the 1. We are done. In this case, if we divide this way, 3 divided by 3, we got what? 1. We are done in this case. So you cannot use 1 because 1 is not a prime number. So at this stage, 3 times 3, which gives us a 30 times 3 times 3. But they do not want it in this way. No, they said, write your answer in exponential form. They told you how to express your answer. So which is exponential form? Writing in terms of the powers. 2 is multiplying itself how many times? 2 times. So that's 2 to the exponent of 2. 3 is multiplying itself how many times? 2 times. So that is 3 to the exponent supposed to be. Then they are saying the number 540 as a product of its prime factors is, they gave us the answer for 540. Determine the LCM and HCF of 36 above, as well as your answer to question 2.21. Why question 2.2 here is the same 36 that we simplified here. So these are the two numbers, the 36 and also to find or to determine the LCM. Remember, the LCM is the lowest common multiple. It is common throughout. So if we are given, okay, this is LCM, guys, not to say it is common throughout. It is when you divide by the number, we are going to obtain like an exact value, but being the smallest value of all the multiples, we need the lowest one. So how do we take this number? They are exponents. Take note how you wrote your 36 here, right? Take note of your 36 and your 504. This is our 36. This is our 540. The answers are given in exponential form. If we check. So in exponential form, the LCM is the one. If it is common, you take the one that has got exponent. If it is common, like what we see here, 2 and 2 is common. So which one is got the highest exponent? In this case, they are of the same exponent. So we're just going to take as 2 is best described on 3. Take note on 3. This is 3 to the exponent of 2. This is 3 to the exponent of 3. Which one has got the highest exponent there? That is the 3 to the exponent of what? Of 3. This one. It is the one with the highest exponent. So that's 3 times what? 5. There is a 5 here. Yes, we do not have a 5. For a multiple, you take every number that is occurring, every number that you see. Where it is common, that is where you compare and take the highest one in terms of the exponent. But if the number is not common like this 5, you just have to take it as it is. So you take that one as a 5. So in this case, do not even waste much of your time. This information and the answer is enough for us to obtain the one. Because this is 2 marks. Meaning you say one is 1 mark, another one is 1 mark. So that's just 1 mark. So that's 2 to the exponent of a 2 times 3 to the exponent of a 3. Then whatever that you're going to have here, you multiply by a 5. That was going to give us 540. So as we can see, this was going to be 5 common factor out. And where it is common throughout, you take the part where we have the smallest exponent. But the first thing, it must be common throughout. 2 is common throughout. As you can see, there's 2 and 2 here. Which one that has got the smallest exponent? They are the same. 2 and 2 here. To the exponent of 2, 2 to the exponent of 2. 3 is common. There's a 3 here. There's also a 3 here. Which one that has got the smallest exponent? 3 to the exponent of what? Of 2. 5 is not common. We do not have it here. For the highest common factor, we do not take a number which is not common. The first thing, it must be common throughout. Common throughout. It must be common throughout. If it is not common throughout, you're not going to take that number for the highest common factor. So that was going to give us 36. 2 marks, just one guess there. That one was just a direct question where we just needed this direct information. 12 contractors. There are 12 contractors can build and 12 contractors. They are going to take 7 days to build what? An RDP. Then how many contractors working at the same rate will be needed to build the house in 4 days? How many contractors are we going to have? That is the question. All right, this is a question which is focused on a rate. So when you consider a rate, be careful because this is the consideration of a rate. Let's take a normal consideration, which is not of a rate. Let's take just a normal question. A normal question. All right? Like you are given, let's say the issue of sales. You are selling, let's say you sold 3 items and they were at a cost of 120 Rand. These items, they are of the same price. So you sold 3, then you got 120. Then you're being asked, what about 5? What is going to be the total if they are of the same, they are of what? They are of the same price. How are you going to simplify to find the unknown value? Let's call it M price. This type of a question, 3, if it gave you 120, the 5 is going to give you more. That's a normal consideration that we are used to. 5 is going to give us what? 5 is going to give us more. The smaller the number, the smaller the value, the bigger the number, the bigger the value. That is what how you on a normal consideration. So in that case, you're going to cross multiply. In order for you to find x, you cross multiply when it is like that to find your x. But in this case, when you are dealing with the same rate of work, guys, it is different now when dealing with the rate of work. You're dealing with the rate of work. It is an inverse proportion that you are considering. It is an inverse proportion that you are working with. You are working with what? An inverse proportion. In terms of the days, if they are working at the same rate, these are people who are building a house. 12, they need 7 days. So guys, the lesser the days, for us to have fewer days for them to finish this same RDP and in 4 days, look at the days they are less. It does not mean we need less people, you know. It is the opposite now. We need more people to finish, which is X. We need more people there. So in this case, we are going to need more people, but being taken from a lesser value. The more that we are seeing, it is from a lesser value. Take note, it's from a lesser value. It is not to correspond like what we have to say, this is 1, this is 5. If it is 3, if it is something that is obvious to say 1 is 5, so 3 is going to be more. In this case, the bigger the value will be having lesser value in. The bigger the value will be having lesser. The smaller the value will be having bigger. So we are going to have more contractors in order for this work to be finished in within 4 days. For a few days, we'll be needing more people for a few days. So in that type of a question, we are not going to cross multiply like I was saying, to say when it is a normal consideration, which is an obvious case that when one is this, the other one is going to be more. You cross multiply. This time, you multiply along your values. You want to find the value of x. So you can simply multiply your values along like this. So it is going to be x times 4, which is 4x is equal to, you multiply these ones along like this, 12 times 7. So it will be equal to 12 times 7. So since we need x, we are simply whatever that we are going to give us 21. 21 contractors in the build. This is 4 days. We need what? 21 contractors. So are we seeing fewer days, more number of people? For many days, look at the contractors, they're less. So this is, or when you're dealing with the rate of work, you're supposed to be very, very careful on that one. The way that you are going to present your simplification you must be careful. On 3.1, which is a question 3, arrange in ascending order, meaning to say we're going to start with the least value up to the bigger value. So the least with negative, that's negative 62 there, followed by negative 43, all right? The positive, the smaller, is 8, followed by 25, like that. So this is the smallest value going to the biggest in ascending. The opposite, if they say descending, you start with the least going to the maximum value, which is the biggest value. Evaluate without the use of a calculator, meaning to say we just need to simplify. 1 is 7 minus a 2 over what? 3 plus minus 2 to the x minus 2 times minus 2. 4 times minus 2, that's a minus 8. Positive, negative, it'll give us what? A negative. So you're going to have player. So you're going to have plus minus 8. Whatever that you're going to have here, multiply it to what? To 5 at the end. All right, let's see what are we going to have. 7 minus 2, that's a 5. Over what? Plus 8, guys. A plus and a minus, it's a minus. So it's simply 3 over minus 5 times a 5. So what are we going to have? This one and that, it's minus. So it's same as we've got minus 1 there, times 5. Of which minus 1 times 5 is what? Is we have there. Question number 4, complete the exponential law by filling the missing part. What are we going to have? Which law is it that gives us 1 over a exponent? 2 to the exponent of minus 3. Remember, that's 1 over 2 to the exponent of 3. I just want you to know your laws of your exponents. 4.2 you're given, plus 4 times p to the exponent of minus 2x, p squared to the exponent of x plus 1. So that's a squared here. So if we are to, they're going to distract me. Need some space to simplify this. So if you are to consider, remember multiplication, if you are multiplying the base, going to add the exponents, a plus b, going to add. So there we are multiplying, so simply going to add there, which is p to the exponent of 4x plus 4 with minus 2x minus 2 like this. That is what we are adding. Plus and a minus, it's what? It's minus. We have to add, but as we are adding, consider the sign. There is no effect. It is just going to remain as it is, the sign as it is. In the denominator, there is p to the exponent of 2, exponent of a to the exponent of b. Remember, it is x to the exponent of ab. Exponent, you multiply. So 2 was going to into x plus 1. You multiply everything. So it's 2 times x, which is 2x plus 2 times 1, which is 2. All right, so let's see here on top as we are to combine our terms. Collecting the like terms, we have got the part where we have got p, this 4x and 2x. These are like terms, 2 there. So let's simplify and see that's p to the exponent of 4 minus 2, which is 2x. 4 minus 2 here, that's a 2. So that's a plus 2 over p to the x. 2 are the same. You can even cancel this and say you've got a 1. Or using the laws, we are dividing this time the exponents. We are dividing these bases, which are the same. So the part of to subtract this exponent of 2x plus 2. All right, so that's put a bracket, everything. So this is what you're going to have. It is going to be 2x plus 2. We distribute by this negative, just like negative 1 times 2x, x, negative 1 times 2, that's a negative 2. As we are to consider that, we can collect the like terms just like the previous case. We saw that the part of our like terms, the stands, the 2 and the minus 2. What are you going to have there? That's a 0 there, all right? 2x minus 2x, that's a 0, plus 2 minus 2. We understand that any number, when raised to the exponent of a 0, it is going to give us a 1. So that is where we're going to end up with our question when simplified properly, following the laws of our exponents. As you are to consider your laws of exponents, it is very, very important that you do revise your basics. They tried to work with the introductions. So it's true that some of the topics we didn't manage to finish up, but work with introductions, understand your a pattern using squares. In the first arrangement, there are two squares. As you can see, there are two squares. She used 5 squares, okay? The second one, and the second she used 5 squares. The second one, there are 5 squares. But there's something that I want you to see about this row, these squares in a row, because definitely you have to study. That's why they extend it, but study what is happening. So the first one, in this row, there are 2. The second one, if we check in this row, how many numbers do we have? 1, 2, 3. 3 boxes. There are 3. Focus on this part, only this one. You see what is happening. 1, 2, 3, 4. There are 4. So they are now saying, if you use that same information, sketch, then all the squares will be arranged in the 6th pattern. In the 6th pattern, like this is the 5th, and you're going to have the 6th and so on. So considering this, the first one, there are 2 numbers in a row like this. In this middle row, there are 2. In the second one, there are 3. Okay? In the third one, there are 4. What is happening? What about 6? The 6th one is going to be 7. So you're simply adding a 1. First, there are 2. Second, there are 3. Third, there is 4. Fourth, 5. So to the 6th one, you know that is going to be 7. So there are 7 in these mid boxes that we are going to have like this. All right? So let me try to show you. Let's just hope it's not going to affect. This is too faint. This is too, I didn't want it to be like this, guys. All right? Let's hope all these boards, once you do something like this, they can tend to misbehave. Okay, I knew it. You see. All right, so let's just hope this is not going to affect you guys, that these softwares. But like I was saying, remember I was saying there we've got 2. We ended up having here, we say these are 3, 4, and so on and so on. So meaning to say for this 60 pattern that we are going to have 3, 1 is 2, 2 is 3. So you're simply adding to this number 1. 3 plus 1, that's 4. 2 plus 1, 3. 1 plus 1. So 61. So it's just 6 plus 1, which is what? 7. So in this row, we are going to have 6 of these boxes, like this box, smaller boxes that we have going to have 6. So that'll be like this: 1, 2, 3, 4, 5, 6. So it's going to be too much here. So let's just do it this way. That's to have a 7 there. Let's try to reduce this somewhere there, something like this. All right, so that's 1, 2, 3, 4, 5, 6. Guys, I'm supposed to have 7. What happened to the 7th one? The 7 now. Like we have got 1, 2, 3, 4, 5, 6, 7. This is this row, this one. They're supposed to be 7. So if you take a closer look, are you seeing that the first one, we do not have anything on top here because we do not have, like, if there are 3 boxes, you can see that there's a box that there's a part that we leave here, and this part that we leave, then we're going to have something there. Just like what here, there's a gap, then in between, there are boxes that are there. So means we're going to leave a gap here, we leave a gap, but in between here, we are going to have what? Boxes there in between. We're going to have these ones there, we're going to have down also, on top, and also down. So this is, guys, just, it was going to be like this. So that's like this. All right. So meaning to say, if we were to count these, it was going to be this 7. All right, then we've got 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All of these, they were going to be 17 square. Was it? Study something. Be very careful. You have to study and present the way that you're given. 5.12, use the table below. From this table, okay, from this table, determine the algebraic formula for Tn, relating the number of squares to the pattern number. The pattern number of squares. So we're given, guys, this is n like 1, 2, and so on. So you just have to check what is the happening between these terms, between the first one and the second one. So let's find the difference. 5 minus 2, that's a 3. 8 minus 5, difference of 3. This is representing what you call a linear pattern, just like what you had in your grade 8 mathematics, a linear pattern where Tn is equal to the difference that we are going to have here times n plus a certain value that you need to calculate, which you are going to call it C. So this part here, the difference is what? The difference. What is our difference? The difference is 3. So we're supposed to add a certain value. What we do, we do not know this. So how are we going to obtain this value here? We can just call it C, okay? So let's just call it Bn plus C, where B is the difference and C is the value to be determined. They are saying the pattern number n is equal to what? To 1. At that moment, Tn is what? Is 2. So when n is 1, substitute n here, which is 1, and Tn is going to be what? 2. So Tn, this one, is 2 when this is a 1. You can use the second one versus a 5. You can use the third one versus 8. It is up to you. You're going to obtain the same. Calculate this. So 2 is equal to 3 times 1, which is 3, plus C. Take this to the other, which is minus 1. So minus 1 is equal to 7, must be equal to 3n, this one. 3n plus C, where our C is what? Plus 1. So that's how you're going to have your algebraic formula from this information that we were given. So you just have to be careful. The simplification there. 5.13 determined here using that formula Tn to determine the pattern number, to determine n, what is the value of n, if there are 101 squares. If Tn, remember the squares represent what? Tn here. Number of squares, it's what? It's Tn. Pattern number, it's n. Number of squares, it's Tn. So wherever we see, now we are given that Tn is 101. At that moment, what is the value of n? It's an equation, because we have to substitute where Tn01 is equal to 3n minus 1. In this case, you must solve for what? For n. We are back to your equations. How? 101 plus 1, which is equal to 3n, divide by 3 to find the value of n. So this was going to cancel. Remember, that's a product. 102, we're saying there are 34 numbers that we are going to have in order for us to have 101 squares. Go to 8x minus 3. For these elements of x, minus 2, minus 1, remember x is the input. That's the input. So they asked you to fill in the in, y is equal to what? 8x minus 3. We are given the rule in this formula. Hence, determine the output values. So they say fill in the input, because we are already given. These are the x values. We already have the input there. The input values are already there. So in that order, minus 2, followed by what? By 1, followed by 2. We are already given. Remember. So what is that they want you to do? To obtain now the output values. So guys, this is 5 marks. Like you substitute, this is just one mark. So you can even use your calculator, guys. Y is equal to 80x, x, substitute, minus what? Minus 3. What is the value of y that you're going to have? 80 times minus 2, which is what? Y is the output. We are obtaining minus 19. When x is minus 2, output is minus 19. So like I said, guys, it's a rule that you can even use your calculator and simplify straightforward. This is 1 mark, guys. Okay, this is just 1 mark. On our calculator there, that is 8. You open a bracket, you substitute minus 2, like this. What are you going to do after that? We subtract a 3, like this. What is the value? Minus 19. So you can even fill in up to the end, guys. Fill in. What is the next one? The next one is minus 2. So in place of x, next one, that is minus 1. So in place of x, you're going to substitute here. We remove this and put minus 1. It is going to be minus 11. So as you can see, we're going to obtain minus 11. You move on to 0 there. When x is a 0, you substitute inside of the bracket. You remove that and put a 0 inside of the bracket. That's a minus 3. You can simply have these values. When x is 1, you do the same thing. You substitute inside of this bracket. Remove that. When x is a 2, you do the same thing inside of that bracket. Substitute a 2 there. That is going to give us 13 like this. So you have the output values from the input into the end by substituting you there. That is it, guys. So if you have worked with our intro, we have been working with these introductions, guys, you see that it is just a mere repetition that is happening there. 6.1, given this expression, they are saying 6.11, what is the coefficient of x? What is, where we have x, what is the coefficient? Remember, the coefficient is the term or a number that is affecting that is x squared. Where we have x, it's here on 3xy, on this plus 3xy cubed, like this one. That's where we have x. So what is the coefficient of x? Everything that is. So the coefficient of x in this case was going to be what? Plus 3y squared. So that's 3y squared. A plus, remember, you can just write as it is. That's to the exponent of what? 3. 3y cubed to the exponent of 3, as it is given there. All right. So that is it, guys. 6.12, right? The expression in descending powers of x, descending, that is reducing, starting with the highest exponent where x is the highest exponent y there, followed by what? All right. That's a plus. So we do not have like to separate. It's like being added. The highest is 3, followed by what? By 2. X raised to the exponent of 2. That's a plus there. 5x squared. Where x, the 3, xy cubed. You just have to write as it is, adding like as it is given there, but just starting with what? The highest exponent, followed by this exponent of 1. Remember, x is x to the exponent of 1. Reducing, that is descending powers. Ascending powers, you'll be starting with 1, 2, 3. That is increasing, all right? But opposite for descending, you start with the highest one to the smallest exponent. X plus y squared, like this. Remember, if you're given a squared, it is the first squared. You raise that to the exponent of 2, plus 2 times the first times the last, plus the last squared plus y squared. Remember your algebraic identities. Or you can expand this. There are 2 brackets if you're given this way. X plus y squared means there's another bracket there of x plus 2 squared means 2 times 2. So even for brackets, a bracket squared, it means that bracket is multiplying itself. So we can expand. Remember your FOIL method. Expand starting with this x. All right. X multiplies everything in the second bracket. X multiplies. All right. Then x multiplies the next one. X times y there. That is going to be plus xy. You're done with x. You move on to the next term in the first bracket. Still in the first bracket. You need to next term, which is y there. It multiplies the second bracket just like what we had. So it's y times the first term there, which is y times what? Y is same as what? Is same as xy. We can write it that way. So that is plus xy. That's y times y there, which is y squared. Considering the like terms, we can see that there's a part of xy and xy here. These are like terms to be considered. The part of xy, as you can see, there's x 1 plus 1. You are adding the coefficients there, like the number that we are having here. It's a 1. 1 plus 1 plus y squared. So as you can see, we are still obtaining the same answer by using the identities that we talked about, or those algebraic identities of expanding to the exponent of 2. Or you can just use your FOIL method. On 6.22, you're given to 3x squared minus 2x. We can see that x is the common factor. Then divide. X cubed divided by x. How many x's are 3 over x? There are 3 x's there. Just like x and x's will remain 2. So that's x squared. The same thing, the next term, x squared divided by this x. There are 2, you divide by 1. We are going to remain with 1x. Minus 2x divided by x, you remain with minus 2. Everything over what? Let's consider this other part. X squared minus 1. That's a difference of 2 squares. Remember from your factorization, x squared. 1 is a difference of 2 squares. Minus b into a plus b. As long we can write these numbers as raised to the power of 2. X minus 1 into x plus 1. That's a difference of 2 squares that we are having there. That's plus 1. A difference of 2 squares. There's nothing that we can do. The numerator, there is nothing that we can cancel with the denominator, but we can see that there's a quadratic expression here. Let's try to factorize that. The coefficient of x squared brackets, the first one with x, the other one with x. All right, let's just write 2x plus 1, then we finish this one. So like I was saying, since the quotient of x squared is 1, we want to factorize this. Remember your factorization. You want to factorize. So we have x and x, then we consider the minus 2, which is the constant. But when you add, you must get this coefficient of x, which is 1, the coefficient of x. So we can start with minus 2 and 1, 2 and minus 1. Which part, when we multiply, we get minus 2, but when we add, we must get a positive 1. So if we add these 2, you are going to get a minus 1. By add, you're going to get a minus 1, which is wrong. We need a plus 1. If we add these 2, you are going to obtain a positive 1, which is exactly what we need. So these are the factors that we want, a 2 and a minus 1, the terms that we need here. A 2 and what? A minus 1. By having these, it was going to allow us to cancel where x minus 1, there is a bracket of x minus 1. These 2 are the same, so they can cancel. We do not have any other bracket common, so there's nothing that can cancel. The rest 2 over 1, x plus 1. We do not have the power to cancel anything there. A bracket and a bracket be common, you can cancel. If it is not that way, we cannot cancel. So meaning to say, there was nothing that we're going to do there. On question number 7, you were given to identify the values representing the gradient and the y-intercept from the equation. This equation, remember, this is y is x plus c. So m is the gradient, the number that is affecting x. M is the gradient. Remember that. So M is what? 2, the gradient, the number that is affecting the coefficient of x. M is the coefficient of x. So the coefficient of presenting what? The y-intercept. That is our C. And the y-intercept is already given. The number that is given there is what? -5. So that's our y-intercept, like that. So it's of the equation of a straight line. What are the 7.2? Given this equation, calculate the x-intercept. The x, from understanding the equation of a straight line, when y is equal to 0. X, y is the one that you use. Y is supposed to be equal to 0. I you substitute as 0. 3 times 0, that's a 0. Plus 2x minus 3. You need the x-intercept. You need the x value. So you just have to solve this equation. So how do we have the x value? -2 divided by -6 divided by 2, that's a -3. That's 3. Sketch the graph of 3 set of x is provided. So if you take a closer look, this equation, which is the relationship that we are given, is the same as this one that we are given here on top. 3y plus 2x is equal to -6. So already we calculated the x. Know that our graph, it is going to pass through is in the x-axis at direct at -3. In the x-axis, where is -3? -3 is here. So our graph is going to pass here at -3. But we cannot draw a line with only this point. What else are we going to need? We also need the y-intercept of that same intercept of this. 3y plus 2x is equal to the direction. We are dealing with the y, so we find it when x is what? When x is 0. This time it is x which is equal to 0. So in place of x, you substitute a 0 there. So that means 3y, 2 times 0, that's a 0, is equal to what? The value of y. Simply divide by what? By eta. We have the y-intercept, guys. The y-intercept is the at -2. The y value, the y -2. Where do we have -2? Down there. That is where we have -2 here. So these points, guys, they are enough. The line, by joining these 2 points, a straight line is produced from these 2 points. By joining these 2 points that we are given there, a straight line can be what? Can be produced by joining these 2 points like this. All right. So here, guys, just gonna try like this. A straight line that we are given here. 3y plus 2x. So the graphs, this even from your grade 8, I recorded those videos. Make sure that you go through. You see that we have done this, guys. So, guys, I'm not going to explain everything, but if you go through the introduction, you see I explained everything. Just check also your grade 8 mathematics. On question number 7.3, 3 points. This point A, this point B, this point C are points on a straight line graph. Use the points to determine the equation of the line. Okay, the question was right that you're supposed to find the equation of a straight line, but if we check, these points are not on a straight line. If these points are on a straight line, they must have the same gradient. So from, let's say you use AB. Remember, our equation was supposed to be y is equal with our question. This one was actually an error here. Not to say the question they are asking is wrong. No, to use the points to determine an equation is fine. But these points, they are not on a straight line because they don't have the same gradient. Remember, M is the gradient. Okay, is the change in y over the change in x. y2 minus y1 over x straight line. They must give us same gradient. Let's say, because it's either use A or B, A and B, you can choose any part. Okay, let's say you're working with A and B. What was going to be our gradient if you are using A and B? All right, we're going to call this, okay, remember you're using A and B. So we're going to call this x1, y1, x2, y2. We find our equation. We find, so it was going to be half minus y1 is what? It's 1 over x2. x1 is what? Minus 2 over 3. Guys, using your calculator properly here, you are going to... But let's say use another condition. Let's say you use BC. Okay, this time we are using what? So we're going to call this x1 y2 minus y1. So y2, that's 3 minus y1, which is what? Well, there, simplifying this, guys, was going to give us 5 over 4 over 4 at the end. It means, honestly, wrong. They gave us wrong points. The points that they gave us, they are wrong. We cannot use that. But they just wanted you to find this way to say, okay, since you have the gradient of the n1 that you calculated, let's say you calculated from this AC, you take that and substitute in place of C, 3 over 8 x plus C, where C, this is what they want. If it was from the correct points, it was going to be like this, not lie on a straight line. So this question, it was actually an error. This one, it was actually an error like that because of wrong points there. It is because of what? Wrong points given there. Because of these points cannot be on a straight line. It is impossible for those points to be on a straight line. So that's another thing that you need to be careful. But at the exam condition, guys, you know these guys, there is just going to be marked. All right. On question 8.1, given 5 to the exponent of a is equal to 5 to the x case, the bases are the same. So automatically, the exponents will be the same. That was a direct equation. 8.2, solve for y. 8.21. We are given an equation that's minus 8 minus 6. But in this case, y is not support the fraction. This is the same as over 1 over 1. So remember the LCD concept or the LCM. There is y there, 1 and 1. What is the LCD of these two, or what is the LCM? So the LCM is going to be y there. And every term by that LCD, each and every term. So that's a y, and a y there is going to cancel because the same as y over 1 is on top. So you remain with the negative 8. There you multiply, it is going to give us 2y squared, which is equal to, you multiply this other part, minus 6 times y is what? Is minus 6y. So as we can see on this E2, meaning to say we have formed a quadratic. If it is a quadratic equation, one side must be equal to 0. Remember the format ax squared plus bx plus 0. So take this one to the other side, it becomes a positive. So it was going to be 2y squared. We take the minus 6 this side. Already there's a constant there. Minus 8 is equal to 0. Remember writing in what? Descent 1 and so on, starting with the 2 in terms of the exponent. It's very true. It's a quadratic equation. Very, very true. But instead of working with a complicated quadratic equation, we can even reduce this, because we can use our equation by 2. Just try to reduce your equation before solving, or just divide by 2. That's 2 and 2 there. Divide by 2. That's a 3. Minus 8 divided. You can see the coefficient of y squared is now a 1. So by factorization, we are going to solve by what? Factorization method, considering 2 brackets, obtain 1 y squared. We are going to have y here, y here. Then what are the factors of negative 4? We are back to the product 3. You try, it's a trial and error, minus 4. Which part, when you add, you're going to obtain a positive 3. All that. You're going to see that add these two, we're going to have a positive 3. So that's, plus 4 and a minus 1. 4 is equal to 0, negative 4. If this bracket is equal to 0, you take the minus 1 to the other side. Therefore, y was going to be a positive 1. It was going to be a positive 1. So there are two possible values that we could have determined from there. All right, let's consider 8.22. And that is for y. All right, so this is 4y plus 3. Everything over 5 is equal to, that's 5. I've got two fractions, one on the left, another one on the right. There are two fractions. One is on the left, another one is on the right. So cross multiplication can work. We can cross multiply. That is 1. And this 5 is going to multiply the 5y minus 12. So that's cross multiplication. So 1, distribute it into the 1 times 3, which is a positive 3, is equal to, you distribute by 5 this bracket. 5 multiplies everything. 5 times 5, 60. So meaning to say we can collect the terms of y to one side of the equation, 25 across the equal sign. So it was going to be 4y minus, the moment it crosses the equal sign. So 4 minus 24 minus 21, y is equal to, you take the 3 to the other side of the equation. It was going to be a minus 3 there. So it was going to be a negative 3, negative 3, negative 3. So how can we determine the value of y there? Simply divide by negative 21 by negative 21, so that these can negative 63 by negative 21. It was going to give us a positive 3. Just like that. Just make sure you revise as much as you can. Then on another part, which is 8.3, when even ST is inserted into a computer program, the program reads it as, so you input ST, but on the program, it is going to read as T squared plus ST. So they're saying, if the program is given, this time it's 4x, take note, it's 4x. It was ST, take note. This time it's what? 4x is equal to minus 3. And they're saying, for whatever part that you have, as this is the format, it is not changing. Then what will be the value or values of x be if the format did not change? Guys, look what is happening here. If this is s in terms of t, our expression is written in terms of t. But for us, it is written in terms of what? It is written in terms of x, not t. This is x. So it was going to be x be read as what? X squared plus st. Take note, st, this is the product of this s and t. Here what we have? 4 and x, the product of this 4 times x. So plus 4x gave us that if we insert this rule in the same format that we have here, the answer is supposed to be minus 3. Whatever that you're going to give by inserting this, you're supposed to obtain what? A minus 3. So guys, this is an equation. They want you to find the x values. It's simply to solve. They're saying solve for x. That's a quadratic equation. So get rid of this 3. We need one side to be equal to 0, so let it be to the other side, just like what we saw all those quadratic equations that we solved. So it was going to be x squared negative 3, which is equal to 0. You now have equation by factorization method, because the coefficient of x squared, there's one, you're just going to have two brackets. Remember this, guys? We've been talking about this. This will be x. Considering 3, the constant term, what are the products, the factors that will give us, factors are being added together. They must give us a positive 3. A positive 4, this one. They must give us, going to consider, you multiply the numbers, you get a 3. But when you add the numbers, you're going to get a positive 4. So you're going to think of 3 and a 1. Minus 3, positive 3 here. If you multiply, you get a positive 3. But when you add here, you're going to get a negative 4. So we need the one which gives us a positive, positive, positive. So it's 3 and what? 3 and 1. So these are the numbers, 3 here and a 1 as they are. So for take the 3 to the other side, it was going to be what? A negative 3 there. So x is equal to minus 3. A positive 1, a negative 1. So these are the possible values of x that we're going to have, which satisfies the equation which was being formed with the program that we are given of a computer. But they wanted you to understand, to say it is the same format, st. It is given in terms of t, so it's of x. But here, look, st, so it's supposed to be also 4x. That's how you study that given question. Some of these questions is study the question. So this is what we had, guys, in order for us to obtain the total of 75 marks. It's everything that you're going to have in light as we are revising for the final exams, which are ahead of time. And let me know, guys, on the comment section, which days are you going to be writing so that we can prepare for any other part that is remaining until we write our final exams. Till we meet again.